Screen కనిపిస్తుందా అందరికి? Is it visible to you all?
Yes, sir.
Right. See, in the last class we have completed the solar cell. In that solar cell we have studied the introduction and what is the principle involved, construction, working, materials used, characteristics, advantages, disadvantages, and finally we have studied the applications. That completely we have studied about the solar cell. Okay? Yeah. And can anyone tell me what is the meaning of short circuit current? Short circuit current. Short circuit current ante entama? Can anyone give the answer? And what is the voltage value at short circuit current?
0.
0. What is the power value at short circuit current?
0.
0.
Right. Then tell me what about open circuit voltage?
Maximum.
Which is maximum current or voltage?
Voltage.
Right. What about the current at open circuit voltage?
0.
0.
Right. What about power at open circuit voltage?
0.
0.
Right, good. And where we will get the maximum power point? Maximum power point, where we will get?
Top right corner.
Right, right side top end corner. Okay, if you draw the graph between current and voltage, okay, top end corner right side, you will get the maximum power point. Regarding that 3 points we have studied in detail. Okay, regarding open circuit voltage, short circuit current, and maximum power point. Regarding these 3 we have studied in detail, right? And in solar cell, what is the principle we have used? Principle of solar cell.
Photovoltaic.
Right, photovoltaic effect. Okay. How can we minimize the losses due to reflection?
By using anti-reflection film.
Right, by using anti-reflection coating, we can minimize the losses. Okay, that is completely about the solar cell. That is completely about the solar cell. In that we use the light coming from sun. In that we use the light coming from sun. Okay. Now today we have to start the pin photodiode. See, whatever diodes we are studying now, all are based on light. The source is light. Even from starting, LED, semiconductor diode laser, solar cell, whatever we studied those 3, the source is light. In LED, the light is emitted. In laser, semiconductor diode laser also, the light is emitted. In solar cell, the light is incident. Okay, light is involved. Then in pin photodiode, what we have to principle involved here, what we have to study here, how the light role here. Okay, how the light involved here. In first 3 concepts, in LED the light is emitted, semiconductor diode laser the light is emitted. Okay, in solar cell the light is incident. Then in case of pin photodiode, here also the light is incident. Remember, this is exactly like solar cell. This is exactly like solar cell. Here also the light is incident on the semiconductor junction. Here also the light is incident. Then what is the difference between solar cell and pin photodiode? In case of solar cell, the light should be bright. The light should be bright. That's why we are considering the light coming from sun. The light should be bright. That's why we consider the light coming from sun. But in case of pin photodiode, the light we have to take from anyway. No need of bright light. No need of bright light. This is very responsive. Okay, even very small amount of light incident here. Okay, then electric current will produce. Concept is same. In solar cell, pin photodiode, light energy is converting into electric energy. Okay, is it solar? What is the meaning of solar cell? What is the meaning of solar cell?
It is a photovoltaic device which converts light energy to electrical energy.
Very good. That is the photovoltaic device that converts light energy to electric energy. Even pin diode also, it converts light energy to electric energy. Remember, here pin diode also, it converts light energy to electric energy. The difference is in solar cell, we have to use only bright light. That means the light coming from sun. But in case of pin photodiode, we can use low intensity of light also we can use here. Here we can use low intensity of light also we can use. This is very responsive amount. Even small amount of light is incident. Immediately that will respond. Immediately that will respond and that is converting into electric energy. Okay. Then what is the concept involved here? What is the concept involved here? The meaning of PIN. This is just like PN junction diode. Whatever you have studied in unit 2, that is PN junction diode. Okay, this is almost similar to that one. Structure similar to that one. Concept similar to solar cell. Structure similar to PN junction diode, but concept similar to solar cell. Okay, now we will study one by one point. Here mainly we have to study introduction and what is the pin diode. In construction itself, we will study what are the materials we can use, working, advantages and disadvantages, and finally application. What is the application of this one? Regarding this pin photodiode, we have to study all these contents. Okay. First, we will check one by one. What is the meaning of pin photodiode? Introduction. See here, same concept. It is also consumes light energy to generate electric current. See, a pin photodiode is device that consumes light energy to generate electric current. Okay, what that will do? Pin photodiode is also a device that will take light energy for generating the electric current. Okay, a pin photodiode is device that consumes light energy to generate electric current. Okay, it is also convert light energy to electric energy. What is the another name of this pin photodiode? It also sometimes referred to as photodetector. Okay, this we can use as a light detector. Okay, photo means light. Okay, for detecting light we can use this one. That's why this is very responsive. Even small amount of light is incident on this pin photodiode, immediately that will respond. Immediately the current will emit. Okay, that's why we can call it will work as a photo detector, or we can refer as sometimes photo detector or photo sensor. Okay, it will sensing the light or light detector. This is the different names of the pin photodiode. This pin photodiode we can call as photo detector because that will act as a photo detector, or photo sensor, or light detector. That means that will sensing the photo, like that will sensing the light, that will detect the light. Okay, even very small amount of light is incident, immediately that will detect. Okay, in the form of current that will come out. Okay, a pin photodiode is device that consumes light energy to generate electric energy. For generating electric energy, this pin photodiode consumes light energy. That means that will take light energy. It will converts light energy to electric current only. Okay, what are the another names of this pin photodiode? Based on the concept, based on the application, we can call photo detector or photo sensor or light sensor, light detector. Okay, then in which bias we have to connect? In which bias we have to connect? Generally, ordinary PN junction diode. In which bias we can connect? Ordinary PN junction diodes. Whatever you study in unit 2, the PN junction diodes we can connect in how many bias? Ordinary PN junction diode we can connect in how many bias?
2.
2 bias. What are those? What are those? Entamavi? A 2 bias enti? What are the 2 bias we are using in PN junction diode?
Forward and reverse.
Right, forward bias. Right, good. Forward bias and reverse bias. But this pin photodiode we can connect only in reverse bias. We can connect only in reverse bias. Why we have to connect? That I will explain. See, the meaning of pin. P means P type, N means N type, I means intrinsic semiconductor. Intrinsic semiconductor. Actually, ordinary PN junction diode we are having only P and N regions. Okay, at the junction we are having depletion layer. At the junction, we are having the depletion layer in the p-n junction level. But here, at the junction, we are having the intrinsic semiconductor. Okay, if you use this intrinsic semiconductor at the junction, then the width of the depletion layer should be very large. The width of the depletion layer is very large. Okay, if we connect this pin photodiode in forward bias, if we connect this pin photodiode in forward bias, it will act as a resistance. Remember, it will act as a resistor because no current will flow, because the width of the depletion layer is very high. Okay, here, see, you can observe the diagram. Yeah, this is the diagram. Just you can observe here. This is the p-type region, and this is the n-type region. In between, we are having the intrinsic semiconductor. Okay, this complete intrinsic semiconductor will act as a depletion region. This complete intrinsic semiconductor will act as a depletion layer. If we connect this pin diode, in forward bias, what will happen? The width of the depletion layer is very high. Then it is very difficult to flow the current. That's why this will act as a resistor. No current is flowing here because of large width of the depletion region. Okay, then we can call as resistor. Then why we have to connect in reverse bias? In case of reverse bias, it will act as a capacitor. Remember, in case of reverse bias, it will act as a capacitor. Then how it will act as capacitor? Actually, you know about the concept of capacitors. You have studied intermediate second year. Capacitor means we are having two plates, positive plate and negative plate. In between, we are having the medium. Here also, in this pin diode, P is one electrode, N is another electrode. Between that, this intrinsic semiconductor will act as the medium. Okay, this intrinsic semiconductor will act as the medium. Okay, if you connect in reverse bias, it will act as a capacitor. That point you will clearly studied in working again. Okay, these pin diodes are specially designed to operate in reverse bias condition. Why we have to connect, I will explain again in construction and working. Okay, this is basic point. Generally, if you connect pin photodiodes in forward bias, it will act as resistor. If you connect in reverse bias, it will act as capacitor. Generally, this pin photodiodes we have to connect in reverse bias. Forward bias connect chain dollar. Okay, wherever we are using this pin photodiodes, we will connect in reverse bias. Okay, pin photodiodes are specially designed to operate in reverse bias. Condition. Okay. First one is, what is the meaning of pin photodiode? It is a device that consumes light energy to generate electric current. Directly, we can say it converts light energy to electric energy directly. This is also pin photodiode. Based on application, we can call this pin photodiode as photodetector, photosensor, or light detector. This pin photodiode always we can connect it in reverse bias condition. For that only this is specially designed. This pin photodiode are specially designed to operate in reverse bias condition. Only connected. See here, already I told this is even very small amount of light is incident. Immediately that is converting into electric current. That means it is very sensitive to light. Remember, this pin photodiode is very sensitive to light. When light or photons falls on photodiode, it easily converts light into electric current. Okay, you can observe the third point. Pin photodiode is very sensitive to light, but in case of solar cell, that is not sensitive to light. Remember, that not very sensitive to light. Very bright light is incident, then only that is converting into electric energy. In case of solar cells, very bright light is incident, then only that is converting into electric energy. That's why we are using the light coming from sun. But pin photodiode is not like that. It is very sensitive to light. That means very small light is incident. That is also converting into electric current. Okay. Pin photodiode is very sensitive to light. So when light or photons falls on the photodiode, it easily converts light into electric current. Okay. Even very small amount of light is incident. That is easily converts into electric current. But solar cell is also known as large area photodiode. Solar cell also same concept, but for that we need large area and large light. Concept is same. The conversion of light energy to electric energy in both cases. Okay. Solar cell is also known as large area photodiode. The area of the solar cell should be large because it converts solar energy or light energy into electric energy. Okay. That also converts the solar energy or light energy into electric energy of bright light. However, solar cell works only at bright light. Remember this point. This is very, very important. Okay, solar cell works only at bright light, but this pin photodiode, this will work even with very small intensity of light. Okay, that is the difference between pin photodiode and solar cell. Okay, you can check once again. Pin photodiode means that is a device that consumes light energy to generate electric current. That means this is also converts light energy to electric energy. Based on application, it's also sometimes referred as photodetector, photosensor, or light detector. That means detecting the light or sensing the light. Okay. These pin photodiodes are specially designed to operate in reverse bias condition. Particularly, these are operating in reverse bias condition. And this is very sensitive to light. Pin photodiode is very sensitive to light. So when light or photons fall on photodiode, it is easily converts light into electric current. Solar cell also same concept. Solar cell is also known as the large area photodiode because it converts solar energy or light energy into electric energy. But however, solar cell works only at a bright light. Remember. Okay. Now we can observe the symbol. Is there any difference between symbol of solar cell and pin photodiode? Is there any difference? Both are same symbol, amma. Even solar cell symbol and the pin photodiode symbol is same. In both cases, the light is incident on the diode. In both cases, the light is incident on the diode. In solar cell, we are having only two layers, P type and N type. In between, we are having the junction. The light is incident on the junction. The junction is very small, that is very thin. But here, the junction is very large. Okay, we are using wide depletion layer as a junction. Here we are using wide depletion layer as a junction. See here, the symbol of pin photodiode is similar to normal PN junction diode, except it contains arrows striking the diode. If you remove this arrow marks, then what is the symbol?
PN junction.
Ordinary PN junction diode, right? Okay, just the difference is the arrow marks. The symbol of pin photodiode is similar to normal PN junction diode, except that it contains arrows striking the diode. The arrow striking the diode represents light or photons are incident. This arrow marks represents the light incident on the diode. The arrow marks represents the light incident on the diode. The symbol of solar cell and pin photodiode both are same. If you remove that arrow marks, then that will act as an ordinary diode. You can observe the ordinary diode symbol here. This is the ordinary diode. This is the pin photodiode. This is the pin photodiode. Now we can take pin photodiode like this. This is the P region, this violet color. This orange color is the N region. In between that, we are having the wide depletion width of intrinsic semiconductor. In between, we are having the wide width of matter. This is the intrinsic semiconductor. Okay, this will act as PN junction. This will act as PN junction. In between that, we are having completely depletion region. This is the P type semiconductor. This is the N type semiconductor. In between, we are having the depletion region of intrinsic semiconductor. That means PIN. That's why we can call intrinsic semiconductor this one. PIN. Okay. This is the symbol of the pin photodiode. Okay. This is just like normal PN junction diode only, except the arrow marks. If we remove the arrow marks, that will act as an ordinary diode. The arrow marks represents the light or photons incident on the diode. Okay. Right. Next. The construction and working of pin photodiode is almost similar to normal PN junction diode. Remember, it's almost similar to construction and working, almost similar to pin photodiode of construction working, almost similar to ordinary PN junction diode. The construction and working of pin photodiode is almost similar to the normal PN junction diode. Here, what is the meaning of PIN? P means P type, I means intrinsic, N means N type. Structure is mostly used for constructing the photodiode instead of PN junction structure, because pin structure provides fast response time. Pin structure having fast response time. That means even small amount of light incident immediately. within fraction of seconds that is converting into electric energy. That means that is having fast response time. The reason is you can take intrinsic semiconductor, as a junction. If the light is incident on the intrinsic semiconductor, the electrons absorb that energy. Okay, the electrons absorb that energy and moving from valence band to conduction band inside intrinsic semiconductor. Already you know about the intrinsic semiconductor. At the bottom we are having the valence band, and top we are having the conduction band. When the light is incident, immediately the electrons in valence band absorb that energy and goes to conduction band. Okay, then automatically that will create electron hole pairs. Then that is converting into light. There we use these pin photodiodes, mainly high-speed applications. Pin photodiodes are mostly used in high-speed applications because this is having fast response time. Even very small amount of light is incident, immediately within fraction of seconds that is converting into electric energy. That means we are using this in high-speed applications. Okay. This one once again, this point. The construction and working of pin photodiode is almost similar to the normal PN junction diode. The construction and working of pin photodiode is almost similar to the normal PN junction diode. What is the meaning of PIN? P means P-type, I means intrinsic, N means N-type structure. Okay, is mostly used for constructing the photodiode instead of PN junction structure. The reason is pin structure having more response time compared with the PN structure. Pin structure having more response time, fast response time. These pin photodiodes are mostly used in high-speed applications. Okay. Generally, in PN junction diode, we use the energy source as voltage. Voltage generally used as energy source in ordinary PN junction diode to generate the electric current. But here in photodiodes, we can use both voltage and light. Remember, in normal PN junction diode, voltage is used as an energy source to generate electric current. In our normal PN junction diode, whatever you studied, you need to, in that the energy source is voltage. Okay, voltage is used as energy source to generate electric current. Whereas in photodiodes, here we can use both voltage and light. We are used as the energy source to generate the electric current. This is about pin photodiode introduction. Okay. Next we will study about the construction. Okay, doubt in the first one introduction. What is the meaning of pin photodiode? Introduction is that is a device that converts light energy to electric energy, or that consumes light energy to generate electric current. Both are same definition. Okay, in based on application we can call photodetector or photosensor or light sensor. In which bias we have to connect this one? Always we have to connect this one in reverse bias. For that only it is specially designed. To operate in reverse bias condition only, these are specially designed. It is very sensitive to light. Already I told this is very sensitive to light. Even small amount of light is incident on the photodiode. It easily converts to electric energy, electric current. Okay. Solar cell also having same concept. And the solar cell also we can call large area photodiode. That also converts light energy to electric energy. But the thing is, in solar cell works only at the bright light. But this photodiode will work at the small light also. This is the symbol you can remember. So you can observe. This is almost similar to PN junction diode, except the arrow marks. That is the symbol of almost similar to solar cell. The symbol of pin photodiode is similar to the normal PN junction diode, except that it contains arrows striking the diode. If we remove that arrows, that is acting as ordinary diode. This arrow marks represents the light striking the diodes. And next point, what we have? This is almost similar structure as PN junction diode, but in PN junction diode we are having only two regions, and a P region and N region. But this is having three regions: P-type, intrinsic, and N-type structure. Okay, and here this pin structure having most response time, fast response time. That's why we are using this in high-speed applications. In ordinary PN junction diode, what is the energy source? Now tell me, what is the energy source in ordinary PN junction diode? Energy source in ordinary PN junction diode. What is that one? What is the energy source in ordinary PN junction diode? Next point again. Voltage. In pin diode? Pin photodiode,
Light.
light and voltage both. Light and voltage both there. Okay? Right. See, observe the next point. In ordinary PN junction diode, the energy source is voltage. Here, in case of pin photodiodes, the energy source is both light and voltage. This is about introduction of pin photodiodes. This is about introduction of pin photodiodes. Then what about next one? That is construction and working we have to study. Construction is very simple. This is P region, this is N region. In between we are having intrinsic semiconductor. In between we are having intrinsic semiconductor. Okay, this is the P region, this is the N region, this is the intrinsic semiconductor. Here the light is incident on this intrinsic semiconductor. Then what is the purpose of this intrinsic semiconductor? Why we have to include that one? What is the purpose of that intrinsic semiconductor? The reason behind that will increase the minority charge carriers, remember. That will increase the minority charge carriers. Okay, if you introduce this intrinsic semiconductor between this P-type and N-type, this will increase the minority charge carriers. That is the main purpose. Even small light is incident, that minority charge carriers will respond immediately. Okay, if the light is incident on this intrinsic semiconductor, those minority charge carriers respond immediately. Okay, see here. A PN junction photodiode is made of two layers. Generally, you can take PN junction diode, not pin diode. In case of PN junction photodiode, is made of two layers, namely P-type and N-type semiconductors. Okay, just like solar cell or LED. PN junction photodiode means that maybe solar cell or LED. In that, we are having only two layers. Those are P-type and N-type semiconductor. Whereas pin photodiode is made of three layers, namely P-type, N-type, and intrinsic semiconductor. In construction, you can observe in PN junction photodiode is made of only two layers. That made of only two layers. Those are P-type and N-type semiconductors only. But in case of pin photodiode, we are having the three layers. What are those? P-type, N-type, and intrinsic semiconductor. P-type, N-type, and intrinsic semiconductor. Then what is the use of that intrinsic semiconductor? We will observe. In pin photodiode, an additional layer called intrinsic semiconductor is placed between the P-type and N-type semiconductor to increase the minority carrier current. Remember, to increase the minority carrier current. In case of PN junction photodiode, the minority carrier current is very, very small, almost neglected. In case of PN junction diode, even you studied PN junction diode in forward bias and reverse bias. In that forward bias or reverse bias of PN junction diode, what is the minority current? That is almost neglected. Even in forward bias or reverse bias, okay, we have considered only majority charges current. In reverse bias, there is no current in PN junction diode. So just you can recap once again. You can remember once again that PN junction diode. In forward bias only the current flowing through the circuit, that is also due to majority charge carriers. Okay, the current due to minority carriers almost we neglected in PN junction diode. Even in reverse bias also there is no current. Whatever current we got due to minority charge carriers, that is very, very small. But here the introduction of that additional layer, that is increase the minority carrier current. That is the main point here. In pin photodiode, an additional layer called intrinsic semiconductor is placed between the P-type and N-type semiconductor. In pin photodiode, an additional layer called intrinsic semiconductor is placed between the P-type and N-type semiconductor. That will increase the minority carrier current. Very, very important. You have to remember that point. Okay, the purpose of that intrinsic layer, okay, that will increase the minority carrier current. This is about construction. Construction, this is very simple construction, only 2 points. And you have to draw this diagram. This is the P-type, this is the N-type, this is intrinsic semiconductor. The light is incident on here, that will increase the minority carrier current. Okay, even very small amount of light is incident, that will very fast responsive, that light is converting into electric energy immediately. Okay, this is about construction. Now we have to study about working in detail. Working in detail ga study chadam. Okay, working in detail ga study chadam. Right. Now we will check about the working. You can observe the diagram in detail here. Okay, you can observe P-type region. This is very small region we are looking. N-type region. This is also very small we are looking. And in between we are having the depletion or intrinsic region. depletion or intrinsic region. Now tell me in which bias we have to connect this one? Pin photodiode. Which
Reverse
bias?
bias.
Reverse bias we have to connect, right? Good. Reverse bias means P type is connected to positive terminal or negative terminal.
Negative term.
Good. P type is connected to negative terminal of the battery, and the N type is connected to N type. There is
Positive.
connection, right? N type is connected to positive terminal of the battery. Okay, this is specially designed for reverse bias condition operation. Okay, this P type is connected to negative terminal of the battery, and N type is connected to positive terminal of the battery. Right? In between, we are having the depletion or intrinsic region. Okay, that is intrinsic semiconductor. Right. Now we can observe a pin photodiode is made of P region and N region separated by a highly resistive intrinsic layer. Separated by a highly resistive intrinsic layer. A pin photodiode is made of P region and N region separated by a highly resistive intrinsic layer. Generally, in case of intrinsic semiconductor, the current we are getting, that is very, very small, remember. Because we are not added any impurity. Intrinsic semiconductor means we are not added any impurity. Okay, elanti impurities undavu. That's why that is highly resistive we are calling. A pin photodiode is made of P region and N region separated by a highly resistive intrinsic layer. That intrinsic layer is placed between the P region and N region to increase the width of the depletion region. Generally, in case of reverse bias, tell me the answer. In case of reverse bias, the width of the depletion region increases or decreases? The width of the depletion increases. Okay. In case of forward bias,
Decreases.
in case of forward, decreases, right? Actually, here we are connected in reverse bias condition, then automatically the width of the depletion region increases here. Already we are having intrinsic semiconductor in between. Okay, that will act as a depletion region. When we connect it in reverse bias, again that will increase the more width. Okay, we are having the large depletion region width. Okay, this is having large depletion region width. That is also one of the advantages. If we are having large depletion width, then that is more responsive to light. Remember, మనకి ఎక్కడైతే large depletion width ఉంటుందో, that is more responsive to the light. Okay, this is one of the main reason we are introduced to that intrinsic semiconductor, and we are connecting in reverse bias. The main purpose of connecting reverse bias, that will increase the width of the depletion region. When the light is incident, immediately that will responsive. That is immediately converting into electric energy. Okay, a pin photodiode is made of P region and N region separated by a highly resistive intrinsic layer. This is the highly resistive intrinsic layer. Here we are having the orange color balls are electrons and white color balls are holes. White color balls are holes and orange color balls are electrons. Orange color balls are electrons. Right? This is the P type. In P type, we are having the majority carriers are holes. That means white color balls. In N type, orange color balls, and this is electrons are majority carriers. These orange colors are electrons. But minority carriers are also there. In N type, minority carriers are holes. In P type, minority carriers are electrons. P type minority carriers are electrons. Right. See here, when it is in reverse bias, what this negative terminal will do? మనకి చెప్పాం already. In reverse bias, the width of the depletion region increases. How? If the positive terminal of the battery connected to P type, N type, and negative terminal of the battery is connected to P type, then what will happen? This negative terminal connected to P type, then what will happen? What that negative terminal will do?
It attracts the holes.
Right, that will attract the holes. Okay, now this negative terminal attract the holes from the P type, and this positive terminal attract the electrons from this side. Then automatically the width of the depletion region increases. మనకి width ఎంత increases అంత మంచిదన్న ఇక్కడ. ఎందుకంటే that is more responsive to light. But in ordinary PN junction width increases, that is not good. Remember, in ordinary PN junction diode, okay, if width increases, there is no current. But here we are using light responsive materials. That's why this is very useful. If width is more, then the advantage is also more here. See, next one. Here, whatever p type and n type we are taking, those are heavily doped. Those are heavily doped. What is the meaning of heavily doped? If p is heavily doped, what is the advantage of that one? If p type is heavily doped, what is the advantage of that one? That is having more number of charge carriers, that means holes. If n type is heavily doped, that is having more number of electrons, those are charge carriers. Okay, heavily doped. We have to use this p type and n type are heavily doped. The p type and n type semiconductors are heavily doped. The p type and n type semiconductors are heavily doped. Therefore, the p region and n region of the pin photodiode has large number of charge carriers to carry electric current. Okay, here p type and n type semiconductors are heavily doped. Therefore, p region and n region of the pin photodiode has large number of charge carriers to carry electric current. That means we are having a large number of charge carriers. But in ordinary PN junction diode, those are not heavily doped. Can anyone give the answer where we did heavily doped in second unit? That means generally where we heavily doped in ordinary PN junction diodes? Ordinary PN junction diode heavily doped కనుక చేస్తే దాన్ని ఏమంటాం? What we can call?
Zener diode.
Right, very good. Zener diode. Okay, heavily doped diodes are Zener diodes, not ordinary PN junction diodes. But here these are photodiodes. These are photodiodes. Here also p type and n type semiconductors are heavily doped. Here also the p type and n type semiconductors are heavily doped. Therefore, the p region and n region of the pin photodiode has large number of charge carriers to carry electric current. The reason behind that for getting heavily doped is that is having large number of charge carriers. That is having large number of charge carriers. That means more number of electrons in n type and more number of holes in p type. However, the charge carriers will not carry electric current on reverse bias condition. In which bias we are connecting here? We are connecting in reverse bias. In reverse bias, we won't get current. In reverse bias, we won't get current due to majority carriers, remember. In reverse bias, initially we won't get current due to majority carriers. Okay. However, these charge carriers will not carry electric current under reverse bias condition. Can anyone tell me answer when we get the electric current? When we get the electric current in any diode, not only this pin photodiode, ordinary diode, Zener diode, you can take any diode, even in forward bias or reverse bias, whatever it may be, when we get the current. మనకి కరెంట్ వస్తుంది అని చెప్పాలి, ఏం చేయాలి, ఏం జరగాలి అక్కడ? What that has to happen? When we get the current, electrons and holes to move across
depletion region.
Very good. Across depletion region, that is across PN junction. Holes are electrons that has to cross the junction. Then only the current will flow in the circuit. But in case of reverse bias, there is no possibility. This negative terminal attracts the holes. The positive terminal attracts the electrons. No charge carrier is cross the junction here. From p type, no charge carrier cross the junction. From n type, no electrons cross the junction. That means we are not getting any current due to majority carriers here, because that is reverse biased. Okay, see here, the p type and n type semiconductors are heavily doped. Therefore, p region and n region of the pin photodiode has large number of charge carriers to carry electric current. But however, these charge carriers will not carry electric current under reverse bias condition. Okay, then whatever middle region we are taking, that is intrinsic semiconductor. Intrinsic means that is undoped semiconductor. On the other hand, intrinsic semiconductor is an undoped semiconductor material. Intrinsic semiconductor means that is the pure semiconductor, undoped semiconductor material. Therefore, the intrinsic region does not have charge carrier to conduct electric current. Therefore, the intrinsic region does not have charge carriers to conduct electric current. In reverse bias condition, okay, no current flowing through the circuit. Okay, now we have not incident at light. ఇంకా మనం లైట్ ఇన్సిడెంట్ చేయలేదమ్మా. ఇన్సిడెంట్ చేసిన తర్వాత కాన్సెప్ట్ డిఫరెంట్ గా ఉంటుంది. Okay, we have not incident like that. Okay, just we are taking the p type and n type, and in between we are having intrinsic region. We have connected in reverse bias condition. In that case, from p type or n type, even having more number of charge carriers, we are not getting any current due to reverse bias condition. And the second point, whatever intrinsic region we are taking, that is pure semiconductor. Okay, they are also not having any charge carriers to move. That means there also we are not getting any electric current initially. Now what is happening? Under reverse bias condition, the majority charge carriers in N region and P region moves away from the junction, that we know, moves away from the junction. This negative terminal absorbs the holes from P type, that means that is moving away from the junction. Here in N type region, electrons are attracted by the positive terminal. Those also move away from the junction. Okay. Under reverse bias condition, the majority charge carriers in N region and P region move away from the junction. Then what will happen? Due to that, the width of the depletion region increases. As a result, the width of the depletion region increases. The negative terminal attracts the more holes, the positive terminal attracts the more electrons, then automatically the width of the depletion region increases. Under reverse bias condition, the majority charge carriers in the N region and the P region moves away from the junction. As a result, the width of the depletion becomes very wide. Okay, now the width of the depletion region is very wide. Therefore, majority carriers will not carry electric current under reverse bias condition. Same point. Here also, in reverse bias condition, majority carriers from P type and N type that does not carry any electric current. Okay. Then now we introduce the light. Now we will introduce the light. When light or photon energy is applied to the pin diode, ఇప్పుడు మనం light incident చేద్దాం. When light or photon energy is applied to the pin diode, then what will happen? Most part of energy is absorbed by the intrinsic or depletion region. Okay, మనం ఏదైతే light incident చేస్తున్నామో, that most of the light is absorbed by intrinsic or depletion region because the wide depletion width. Here that is having more depletion width because that is connected in reverse bias. Okay, that is having more depletion width. That is having more depletion width. The maximum light energy incident that is absorbed by that intrinsic region only. As a result, a large number of electron hole pairs are generated because there is intrinsic semiconductor. Initially, all the electrons are present in valency band. When the light is incident on that intrinsic semiconductor, the electrons in valence band absorb that energy and goes to conduction band. That will generate the electron hole pairs. That will generate the electron hole pairs. When light or photon energy is applied to the pin diode, most part of the energy is absorbed. Most part of the energy is absorbed by the intrinsic or depletion region. Most part of the energy is absorbed by the intrinsic or depletion region because of the wide depletion. Then as a result, a large number of electron hole pairs are generated. Okay, more number of electron hole pairs are generated in the depletion region. Right? Then free electrons generated in the intrinsic region because the light energy is absorbed by electrons in the valence band. Then those electrons got free. Okay, free electrons వచ్చేసాయి. Free electrons generated in the intrinsic region, okay, move towards N side. Move towards N side. See here. Why? What is the reason? See here. Suppose you can take the free electrons in this region that is attracted by, okay, this positive terminal. That means the electrons here, those are moving towards N-type material and this coming to here. That means those are crossing the junction. Whatever electrons are created in intrinsic semiconductor, those are crossing the junction and move towards N side. Free electrons are generated in intrinsic region, move towards N side, whereas holes generated in intrinsic region move towards P side. Okay, this is completely intrinsic region. In this completely intrinsic region, we are getting electron and hole pairs. Whatever electrons are generated in this region, those electrons are cross the junction and move towards N type. Whatever holes generated here, that holes are cross the junction, move towards P type. Okay, these electrons or holes are crossing the junction, automatically we will get the current. When the light is incident, electron hole pairs are generated. When the light is incident, most of the light energy is absorbed by intrinsic region. Then electrons and hole pairs are generated. In that, all electrons are moved towards the N type and cross the junction, and all holes are cross the junction, move towards P type. That means here, whatever electrons and holes are generated in intrinsic region, those are crossing the junction. Then we will get the current. Okay, the free electrons and holes moved from one region to another region carry electric current. Free electrons are generated in intrinsic region, move towards N side, whereas holes generated in intrinsic region move towards P side. Okay, the free electrons and holes moved from one region to another region carry electric current. Like that, we are getting the current here. When the light is incident, very small amount of light is incident, then immediately electrons holes pairs are generated. Then those move towards, electrons move towards n side and the holes move towards p side. Then that will generate the electric current. That will carry the electric current. Right. When free electrons and holes reach n region and p region, electrons will reach n region, holes will reach p region. They are attracted towards positive and negative terminals of the battery. See here, whatever electrons generated in depletion region, those move towards n type, that is attracted by positive terminal. Whatever holes generated in intrinsic region that move towards p type, those are attracted by negative terminal of the battery. Okay, this concept. Next, then the population of minority carriers in pin photodiode is very large compared to PN junction photodiode. Actually, due to that light absorption, okay, in that intrinsic semiconductor, we are getting the large number of minority carriers. Large number of minority carriers. What is the meaning of that? See, you can observe. This is the p-type region. This is the p-type region. In this p-type region, minority carriers are electrons. Minority carriers are electrons. When the light is incident on that intrinsic layer, the electrons are increased. That means the minority carriers are increased here. In case of n type, the minority carriers are holes. Here, the holes are increased. That means due to that light absorption by intrinsic layer, the minority carriers are increased in n type and p type layers. See, the population of minority carriers in pin photodiode is very large compared to PN junction photodiode. Compared with the PN junction photodiode, in case of pin photodiode, we are having the minority charge carriers population. That is the main difference. Remember, in ordinary PN junction photodiode, the minority carriers are very, very small. But in case of pin photodiode, the population of minority carriers are very high. Therefore, pin photodiode carry large minority carrier current than PN junction photodiode. In PN junction photodiode, the current due to minority carriers almost neglected. In PN junction photodiode, the current due to minority carriers almost neglected. But in case of pin photodiode, the maximum current we are getting due to minority carriers only. Just observe the difference. In case of, tell me in which bias we have connected LED or laser?
Forward bias.
Forward bias. That's why the majority current we are getting due to majority carriers. But in photodiode, which bias we are connecting?
Reverse bias.
That's why here we are getting main current due to minority carriers. Remember the difference. Generally, that LED or semiconductor laser, we are connected in forward bias. The current we are getting there due to majority carriers. But here we are connected in reverse bias. The main we are getting due to minority carriers current. Here, when forward bias voltage is applied to the pin photodiode. Okay, suppose మనం pin photodiode forward bias కనెక్ట్ చేసామనుకోండి, ఏమని చెప్పాము? It behaves like a resistor. ఎలా పనిచేస్తుంది? మనకి రెసిస్టర్ లాగా పనిచేస్తుంది. అదే రివర్స్ బయాస్ కనెక్ట్ చేస్తే కెపాసిటర్ లాగా పనిచేస్తుంది. The reason is in reverse bias. In reverse bias, the width of the depletion region increases. The width of the depletion region increases. That means that depletion region will act as a medium between two electrodes. P-type and N-type are electrodes. In between that depletion region is medium. See, when we connected in forward bias, then pin photodiode behaves like a resistor. We know that capacitance is directly proportional to size of electrodes. Capacitance is always directly proportional to size of electrodes and inversely proportional to distance between the electrodes. In pin photodiode, the P region and N region acts as electrodes and intrinsic region acts as dielectric. In pin photodiode, P region and N region ఎలా పనిచేస్తాయి? ఎలక్ట్రోడ్స్ లాగా, intrinsic region dielectric లాగా పనిచేస్తాయి. మీకు ఒకవేళ కెపాసిటెన్స్ కనుక ఫార్ములా గుర్తున్నట్టయితే, can anyone give the formula for capacitance for parallel plate capacitor? Parallel plate capacitor capacitance. ఎవరైనా గుర్తుందా ఫార్ములా? epsilon naught A by D. C equal to epsilon naught A by D. Are they correct number?
Yes, sir.
ఇప్పుడు then what is the relation between capacitance and D? D is the distance between the two plates. That means
Inversely.
Right, that only we are saying here. We know that capacitance is directly proportional to size of the electrodes. That means capacitance is directly proportional to area of the electrodes. Size means area of the electrodes. And inversely proportional to distance between the electrodes. In pin photodiode, the P region and N region act as electrodes and intrinsic region act as dielectric. ఓకే, ఇంట్రిన్సిక్ రీజన్ విల్ యాక్ట్ యాజ్ డయోడ్. ఓకే, ఇంకా కొంచెం ఉందమ్మా వర్కింగ్, ఇది మనం నెక్స్ట్ క్లాస్లో ఫినిష్ చేద్దాము. ఇంకా ఓకే, మనకి ఫార్వర్డ్ బయాస్లో రెసిస్టర్లా పనిచేస్తే, రివర్స్ బయాస్లో కెపాసిటర్లా వచ్చేస్తాం అన్నమాట. నెక్స్ట్ అడ్వాంటేజెస్, డిసడ్వాంటేజెస్, అప్లికేషన్స్ కూడా చూద్దాం నెక్స్ట్ క్లాస్లో. వర్కింగ్ మళ్ళీ ఒకసారి చూసి, ఓకే, వర్కింగ్ ఐ విల్ ఎక్స్ప్లెయిన్ వన్స్ అగైన్, అండ్ విల్ స్టడీ అడ్వాంటేజెస్, డిసడ్వాంటేజ్, అప్లికేషన్స్, అండ్ ఐ విల్ స్టార్ట్ ది అవలాంచ్ photodiode also. ఇంకా లాస్ట్ వన్ ఒక్క కాన్సెప్ట్ ఉన్నాం. మ్యాక్సిమం ఇన్ 3 classes ఐ విల్ ఫినిష్ దిస్ చాప్టర్. ఈ యూనిట్ మనకి యూనిట్ 3 ఇంకా 3 classes పడుతుంది. మ్యాక్సిమం ఇట్ విల్ టేక్ 3 more classes. ఓకే, రైట్. ఏమైనా డౌట్ ఉందా ఇందులో? పిన్ photodiode, ఎనీ డౌట్?
No, sir.
Right. I will revise once again tomorrow in next class, and we will complete in next class. Okay. Right. Okay, Namma. Close చేస్తున్నాను.
Thank you, sir.
Thank you.